Now, Cisco Certified Network Associate, it's a it's a very important program for any beginners. It teaches all essential fundamentals that someone should know in depth in order to work in a network environment. So it's a very important program than any other high level program. If someone is not understanding this program well, for them it will be very difficult to grow in the field of networking. There are a lot of people who have not done this course proper, but they are surviving in the industry for 15 years. I'm not denying that, but they are not really understanding things, and they're simply managing. They really don't have the confidence when they work. They might have finished a lot of big certification, but because they don't have this fundamental knowledge well understood, they really inside. They may not show outside. They inside they really lack confidence. I've spoken to many people. I found this. So this is an important course. That's why I'm repeating for you, though. We covered some portions earlier. Now, the major focus in this training is what is networking, what all devices that makes this networking happen. Now, when we say devices, the important device is switch, router. We will not be focusing much on firewall, though it is an important device. This CCNA is not a security one, but an introduction to firewall. Deep knowledge on switches, deep knowledge on router, and some introductory knowledge on firewall, and also some good knowledge on wireless. Because today we all move to wireless. Your cell phone is wireless, your iPad is wireless, your laptop is wireless. Even if you go to shopping mall, they scan the items that you buy. It's an infrared, it's a wireless. They don't even need to touch the product. They simply scan and they say how much that product is. In some places, you don't see people to bill in the billing session. You just put it on the basket and wirelessly it can calculate the amount that you're supposed to pay. It shows you the amount and you pay through some online application in your cell phone, which is also wireless, and payment is done. Communication is over. You communicated to the bank and bank communicated to the shop, and the shopkeeper is happy because he got the money from the bank. Transaction over. Purchase done. All wireless. There are a lot of places where you have free wireless, airport, lot of places where we get free internet wirelessly. So focusing on these things is what in our training you will find. Switches, routers, firewalls, and some wireless device. So not only for a network engineer, for anyone in today's world, if they want to survive uh, without getting cheated by someone, they should have this knowledge. This is not only the course for networking people. This has become a part. Networking has become a part of our life. You see, you cannot manage without a cell phone today. And cell phone is a part of network. So understanding network is very important for everyone, not only for a network engineer. So this is a very good fundamental course in networking. Now, I remember in the previous CCNA when we started, I was teaching you a lot of devices, different type of devices. I'm not going to get into those things because those things are not that important. And that will be boring also for you because it's well-known stuff. You will definitely know what is hub and switch and router, but still, I want to touch some areas like hub. I'm not going to talk about repeater or amplifier. There are no more in the market. But we spoke on the other training. I'm just going to touch what is really necessary. I'm not going to start from the history. In the previous class, we started from the history, which is going to take a lot of time for us. Let us now focus on what is necessary. Hub is one networking device. You will find in some places switches, seen many places, routers. Now we need to know the difference between these three. Switches can also be called as bridges. Bridge. Now we need to know the difference between these three first. First, we need to know this three device and the differences. To understand this three device proper, we need to understand IP address, MAC address. Only when you know what is MAC address and what is IP address and difference between these two, you will be able to understand the role of switch and the role of router. So, what is an IP address? Or what is a MAC address? Both are address, but which one is more important? Both are more important. Both are very important. Uh, how can I say? You see, I have a name, but my name, Jay, is not a unique name. It may be unique in my street, it may be unique in my family, but this is not a unique name. Many are having this name. So when the other J and me in same place conflict, when the other J comes to my place, and there will be confusion now. Which J? So in a in a small location, you cannot have same names. But it is okay to have one in my street, another one in another street. So you can say this J is from that street, and that J is from the other street. So what I'm trying to say here is IP address is like a name, but the MAC address is not that simple as name. MAC address is unique. MAC address is like your fingerprint. MAC address is like your fingerprint. There may be many J, but no J's fingerprint is same. You may see same face, same height, same color, and same name. Very rare case, you may, like a wonder. You may find a person, you may see some person exactly the Xerox copy, the photocopy, and also having same name. Very rare, I'm saying. That can be there, but you cannot see someone having same fingerprint. Not possible. It's very unique. MAC addresses are like fingerprints. You will not see the same MAC address anywhere. Your laptop MAC address is only in your laptop. Nowhere on earth you will find. It's very unique. And this MAC address is 48-bit size. 48 bits. 48 binary bits. And this IP address is 32-bit size. The version, the IP address version, the IP address has got different version, but there is no different version in MAC address. But in the IP address, you got various versions. But currently, there are only two standard versions. All the rest have diminished, gone. So this IP address is 32-bit if you are using version 4 IP address. If I'll use version 6 IP address, then it is going to be 128 bits. So we got version 4 and version 6 currently. Popular standard versions. No other versions now we have in the industry. They all came like version 5, version 3, they all disappeared because they did not fulfill the requirements. Currently, many part of the world is migrating from 4 to 6. The reason is that 32-bit is not enough to identify all the devices on Earth. To identify all devices on Earth, though IP address can be duplicated, as I said, there is a J here in the street, there is another J in another street. Even though that is allowed, duplication of IP address is allowed, the 32-bit is not sufficient to provide IP address to the entire world. So they came up with another large space IP address, which is called version 6. IP version 6 is 128-bit size, very big. The number 128 may look small for you, but it's very big. 32 and 128, how much is the difference? 96 is the difference. You may say like, oh, what? Just you got 96 bits added and you got 128. How can this be too big? Truth is, yes, it is too big. I want to show you. how IPv6 is very big compared to IPv4. For that, you need to know something about the bits. You know binary bits. Can you say something about binary bits that you know? Maybe you are in mute. You need to unmute. I'm sorry, I'm unable to hear you.
I think it's 8 of them.
I'm sorry?
I don't know. I don't remember.
Okay, no problem. See, bi means what?
2.
Very nice. So there is a number system called binary 0 and 1. This number system is what? Used to build addresses in the networking field, in the computer field. Binary is just two number. We know decimal. Decimal is DCIMAL. Decimal is from the word deca, 10. 10 numbers. 0 till 9. Only 10 numbers. With this 10 number, we are making big, big numbers. For example, if I want to say 2023, this is not a fresh number. This is made out of 2, 0. Again, you repeat the same 2 and then 3. So it's a number between 0 to 9 you are using here to make big number. 3 is from where? In between 0 and 9. 2 is from where? In between 0 and 9. 0 and 2. So we just take numbers in this range, between one of the number in this range or many numbers in this range, and create multiple big numbers. Any number that you use in day-to-day life is simply made out of only this 0 to 9. There is no fresh numbers other than this 10 numbers, 0 to 9. There is no fresh number. Only this 10 number. Likewise. In binary, these two are the fresh numbers. There is no other fresh numbers. 0 means 0. 1 means 1. I'll write here decimal 0. This is binary. In binary, if you say 1, in decimal also 1, no change. But in decimal, if you say 2, how will you write 2 in binary? Simple. You need to put the 0 and 1 here. This is what called as 2. In binary, 1, 0. In decimal, it is equal to 2. How can 1, 0 equals 2? I'll prove how it is 2. Binary, you told me, just two numbers. So this is a place, 0th place. Why I put 2 power 0? Because 2 represents binary. If it is decimal like 2023, I will not say 2. I'll say 10 power 0. You might have done this in the school days. 10 power 1. 10 raised to 2. 10 raised to 3. Because it is decimal, 10 numbers, you put 10. But here we are not dealing with decimal, we are dealing with binary. Binary, only 2 numbers in total. Fresh numbers are only 2. So this is 2 to the power of 0, this is 2 to the power of 1. Now, 2 to the power of 0 is what? Anything power 0 is 1. I think still you are in mute. Anything power 0 is 1. When you multiply 1 by the 0, what do you get? 0. Plus 2 to the power of 1 is what? 2. 2 multiplied by this 1 gives you what? 2. So 2 plus 0 is what? 2. See? 1, 0 is 2. In your school days, they would have taught in a uh, easy way. Like for children, this may be difficult. They might have taught you like this. 1, 0. 0 multiplied by 2 to the power of 0. 1 multiplied by 2 to the power of 1. This is how you might have learnt. 2 to the power of 0 is 0. Sorry, 2 to the power of anything power 0 is 1. 1 multiplied by 0 is 0. 2 to the power of 1 is 2. 2 multiplied by 1 is 2. So what is the total? 2. So 1, 0 means 2. In order to do this calculation, I'm just showing you how this is 2. I just took this 1 here and 0 here. I made another number. But this is not a fresh number. These two are the fresh numbers, 0 and 1. This is made out of these two. Fine. Now, let's do 3. See, this is 2. If 1 is there in this place, you know it is 2. And 1 is there in this place, what is the value? 1. So 2 plus 1 is what? 3. We can also do in this way. You see? 1, 1. Anything power 2 is anything power 0 is 1. 1 multiplied by 1 is 1. 2 power 1 is 2. 2 multiplied by 1 is 2. So write 2 here. When you add this, you get 3. You see? 1, 1 means 3. So for 4, what you will do? 1, 0, 0. This is 4. How? You see? 1, 0, 0. 0, 0, 0 multiplied by 2 to the power of 2. Sorry, not 0. This third one is 1 multiplied by 2 to the power of 2. Now, you see, anything power 0 is 1. 1 multiplied by 0 is 0. 2 to the power of 1 is 2. 2 multiplied by 0 is 0. If you multiply by 0 anything, it will be 0. 2 to the power of 2 is 4. What is the meaning of 2 to the power of 2? It's equal to 2 multiplied by 2. which is equal to 4. 4 multiplied by 1 is what? 4. See? 100 means what? It's 4. Can you guess what will be 5 in binary? What will be 5
1 second.
in binary?
Let me look.
I'm sorry, I didn't get you.
Would it be 110?
1
Okay,
0 1. You see,
101.
in this place, if you have 1, it is 1. In this place, if you have 1,
2.
then it is
Okay.
2. In this place, if you have 1, then it is 4. So we need 5, which means 4 plus 1, you know. This is 4, this is 1.
Okay.
4 plus 1 is 5. Now what will be for 6?
For 6, it'll be 111.
You see, in this place, if you have 1, what is the
2.
value? 2.
That'll be 1.
So now, this place, you know it is 4. In this place, if you have 1, then it is 2. So what will be 6? If I want 6, wait, let me make it easy for you. I was teaching you the actual so far. Let me make it easy, like a shortcut. This place is called 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. When I have 1 in this place, the value in the decimal is 1. When I have 1 in the second place, the value is 2. That's what you got here, 1 0. If I get 1 here, then it is 4. Yeah, 4. If I have 1 here, it will double, you see, 2, 4, 8. Then what is this one? 16. What is this one? 32. What is this one? 64. What is this one? 108. Now, is this 5 correct or not? You see, 1, 0, 1, which means 4 plus 1, 5. Is it correct? Yes, it's correct. Tell me, using this chart, tell me for 6. You're still in mute. I'm unable to hear you. For 6.
Okay, 1 moment looking. You said this.
What 2 number will give you 6?
2, 1. Hold on. It's 4 and 2. We'll give you 6.
Then it should be what? 1, 1, 0, isn't it? See this 3-bit. In this 3-bit, you put 0, then you will have 1 here, which is 4, and 1 here, which is 2. 2 plus 4 is 6. See, if you don't put the 0, what will happen? It will be considered as 3. You got it?
Okay, you take it away. Taking 3, 3. Okay. Yeah, I'm going to have to study this a lot. Because it's a lot. Hold on.
Oh, sorry. Don't worry. You can take your own time. You can use this video repeatedly till you get it. Okay. But don't give it up. Just try to understand. It's the same case, everyone. I was like this when I started. So it'll take some time for us when we are coming from different background. It'll take some time. I was in a psychological background, and I moved to masters in computer science. When they teach me this thing, wow, it was like like a heavenly language. I didn't understand anything, but it took some time. Okay, now, how do you write 7? This is 6. When I put 0 here, this is 6. How will I get 7? When I add this 3, I'll get 7, right?
Correct.
So 1, 1, 1 is 7.
So where does the 0 come from on 6? So
see, this bit I turn to 0 so that anything multiplied by 0 will be 0. So 4 plus 2 is 6. Yeah. Whichever you want to add, for that you put 1. For the other bits you put 0. See, for example, I want to write 15, right? What I'll do, I'll add 8 plus 4 plus 2 plus 1. So I'll put all 4 1.
Okay.
Only then I'll get 15. If I want to write 10, I need only these two numbers,
Yeah,
right?
so you'll do 1, 0.
So what I'll do, 1, 0, 1,
Got
0.
it.
Wow, you got it now. Okay, 10. So let me give you some exercise. Right now, you're going to do this exercise, okay? You can just use this as a reference. You can use this as a reference and do the exercise that I'm going to give you. Are you
Okay.
ready? All right. You write it for 29 and 10 and 100. Can you do this?
Yep. I'll do it right
All
now.
right. All right. I'll just go away for a few. So hub is a dumb box. For some time I passed the recording. I forgot. Now only I resumed it. So I'm repeating. Hub is a network device which is considered as a dumb box because it never learns the MAC address. I told you MAC address is 48-bit size, but for us to easily understand, I have written A, B, C, D as MAC address. These 4 computers with these MAC address, they are connected to the hub for 2 reasons. One is these 4 want to be in a group. Second is when the weak signal cannot travel long distance, we allow hub to regenerate and send it to few more meters. Hub regenerates. But the problem with the hub is it will send the regenerated signal to everyone connected, not exactly to the destination. For example, here, if A wants to talk to D, it not only sends to the destination D, it also sends to other B and C. As a result, as a result, unnecessary bandwidth utilized and unnecessary process being utilized on B and C. That's why we need a device which can learn the MAC address and know who is connected where. That's why we have switch. Switch is a device which can listen to all the packets that is coming. When a packet is coming, it comes with I'm coming from A. Source is what? A. So if it is a switch, it learns that on port number 1, A is connected. Likewise, when D speaks, it learns on port number 4, D is connected. How? From the source address of the packet that enters the switch, switch can learn who is connected. This is not done by hub. And on P2, B is connected. And on P3, C is connected. It learns. It learns MAC addresses. As a result, now if A wants to talk to D, the packet goes to the switch. Switch will refer the table and it finds that D is connected on P4. So it delivers the packet only to D. Only to D. It will send the packet only on P4. It won't send it to P2 or P3. So using MAC address, switches move the packet. Bridge is an older version of switch. Bridge is an older version, so they are not that efficient like switch. In what way switch is better than bridge? You see, bridge uses a software to do all the functions. Only the software with some processor and motherboard. It needs to control all operations of learning MAC address, forwarding the packet, filtering the packet, and so on. All the operations were carried out by a single processor with a software. Only a software should control everything. Whereas switch, it has got more hardware and a software. More hardware and a software will make the switch more efficient. One hardware and one more of software. All the software needs what? Hardware. Then hardware will be too busy. But when we have more hardware and a software, the load of the software can be shared across the hardwares. So you can have now more traffic. Because we know we need more traffic, we use switch now. Switches are hardware-based device, more hardware. Bridges are fully dependent on the software-based device. Hardware-based device, software-based device. Both listens to the incoming packet, learns the MAC address. Incoming frame learns the source MAC address. But bridge and switch are not the same. Switch is more efficient than bridge. Yeah. So switch is an intelligent device and more efficient than bridge. Bridge is also an intelligent device, but compared to switch, less intellectual. Switches are more intellectual. Now, switches looks for only the MAC address to decide where to send. Whereas routers, they decide where to send by looking into the IP address. Routers use IP address to move the packet from one place to another place. Switches use only the MAC address. Let me draw a diagram and explain you this. Are you following me?
Yes.
All right. Let's assume A as a MAC address. MAC address is actually 48-bit size. I don't want to write it and waste time. I'm simply keeping it as A. And now the IP address on this is 10.0.0.1. And there is another computer here. MAC address is B. IP address on this is 10.0.0.2. And I got another computer. MAC address is C. And IP address is 10.0.0.3. Now this three devices, if you see, they all three belong to same network called 10. This is 10 network first IP, 10 network second IP, 10 network third IP, given to these computers to get identified. I told you IP address is like a name of a person. MAC addresses are like a fingerprint of a person. So you can assign any IP address to anyone. But MAC address, not possible. Your MAC address is unique. Only the attackers, thieves, attackers, lazy fellows who don't want to work, attackers, or thieves. Thieves are lazy fellows, crooked people. They only will use our fingerprint, isn't it? Why? To loot our money. Same way, in networking also, why will someone use others' MAC address? Because they want to pretend like you, your computer. Because when your computer asks for access, your company will allow access. You work in that company. So these attackers, those lazy fellows, crooked fellows, they learn your MAC address somehow. They put your MAC address as their own MAC address in their computer and pretend to your network that you are talking. This is what called as network attack. Spoofing, cheating, spoofing. That is possible actually. Someone can use others' MAC address. But MAC address is supposed to be what? Like a fingerprint. It should be unique. If I am not allowed to fly, if I am not allowed to fly, I should not fly. But in order to fly, if I use your fingerprint and cheat the immigration, it's cheating. That is what here people call it as network-based attacks. And they are considered as smart people, those lazy fellows, cheating fellows, stealing fellows. They're considered as smart people because the world is in the devil's hand. All smart, real smart people are not identified. All robots are becoming heroes. Anyway, let's not get into that area. Now here we go. We got MAC address ABC and we got IP address. This switch needs only the MAC address to move the packet. So the switch will know, let's say the port number of this port is P1, P2, P3. So the switch has got a MAC table. Inside the MAC table, it learns like this: P1 connected to A, P2 is connected to B, P3 is connected to C. How it knows? When the packet comes, it comes with a source MAC address. So when switch receives the packet, it looks the source and learns that A is connected on P1. When packet is coming from B, switch learns that on P2, B is connected. How it knows? From looking into the packet. Okay, this is MAC address. And these three computers are in same network. Routers are needed only if we have computers with a different network. You see, this is 20001. This is 20002. So to connect these two, you need a switch. But to connect this group To communicate to this group, sorry. Where are you? Yeah, here, this one. To make these two different network people, see, this is 10 and that is 20. This all begins with 10 network. This is different network. What we need is a router. But this is how we draw a router. Just put a circle. This is how we draw a switch. Now you connect a wire and give an IP address starting with 10 here. 10.0.0.4. This also will have a MAC address. So P4 is connected to MAC address, let's say D. So P4, who is connected? D is connected. Now this link connects to this switch. Let's say IP address here should be starting with 20. 20.0.0, let's say 3. And MAC address is E, F. So this switch now knows that P1, P2, P3, it knows that on P1, E is connected. On P2, F is connected. On P3, G is connected. It learns. And whenever this PC want to talk to another network, it will deliver the packet to this address, router address. Router knows 20, you see, it knows that 20 is connected. Let's say fast Ethernet. That's how we write. F means fast Ethernet. It's a type of link. We'll talk about that later. Fast Ethernet 0/2. This is fast Ethernet 0/1. So router knows that on fast Ethernet 0/2, 20 is connected. So from here, if you are going to 20 network, the packet will go to the router and router will connect them to this interface and it goes here. And this guy knows which MAC address is connected where and he delivers the packet. In short, we'll go in depth in next class. I do not want to overload you. What I want to say here is we have 3 device, mostly same, hub, but not popular because it's always flooding. Switch, it uses MAC address so that it need not to flood every time. And then router is to connect between networks, different network. Switches are to connect between the devices which are in same network. Communicate between the devices which are in same network. That is switch. For that, it uses MAC address. To connect between different network, definitely it needs to look at the IP address because different network means what? Different. Of course, IP address will be different. If here it is 10, it won't be same 10 here. If it is same 10, then it is not different network. So different network only needs router. If you have an office with same network, you don't need router. But take any small network, small office, definitely they will have a router because they will have some departments. Each department will be in different network. If you just recall, you remember we learned subnetting. But anyway, we are going to do those things again. So similar network, same network devices, you need a switch. And the switch will use MAC address to forward the packet, decide who is connected where. Routers use IP address to move the packet. Using IP address, it decides which exit interface the packet should exit. Say, for example, there is another network here connected to some PCs with 30001, 30002. And here the interface name is F0/3, let's say. And this has got IP address 30003. Now, if A wants to talk to that Z here, router will forward the packet like this. It won't send to F02 because router knows 30, all 30. All the address starting with 30 is in this F03 interface. Okay, that's the purpose of router. Router is to connect between networks. Switch is to connect within the same network. And switches use MAC address to decide who is connected where. Hub never uses any MAC address or IP address, so it's a dumb box. It will always flood.
Yes.
Did you understand all that I have spoken today? Right. I'll encourage you to watch this video before we meet in the next class. We'll stop here.